All right. So we're going to start taking a look at some of the subatomic particles that are in the nucleus. Well, not just the nucleus, but in the atom in general. And what their charges are, what their symbols are. Okay. So we're going to fill out all this information here. All right. Now for the proton. Okay. Anybody know what the charge on the proton is? Positive. So its symbol is a P with a little plus sign.
That's a P?
Yeah.
Wait, that's an H. Basically.
All right.
Wait, it's a capital?
It's normally lowercase. Now, the neutron, anybody know what the charge is on the neutron?
Negative.
Neutral. So its symbol is an N.
The degree sign.
Well, yeah, basically. Means it's neutral.
Good job, Macy.
Is that just the circles or somewhere in the middle?
It's,
Just a circle.
yeah. And then what is the charge on the electron? That is negative. So it gets a little E with a negative
It's a
sign.
neutron.
Why did you write it from the bottom?
I'm left-handed.
It has nothing to do with
What
it.
does that have to do with anything?
It doesn't matter.
Wait, what? How'd you write it?
He wrote it like this.
We're so mean to him. Let him do his handwriting.
Yeah.
My mom's a kindergarten teacher, and that's not how she taught me to write my E's.
Oh, okay.
Well, not everybody's her mom.
They also don't teach cursive anymore.
Back to your garden level.
Jimmy, your method didn't
Not
work.
everybody's your mommy.
That's right. All right, so your charges are positive, neutral,
I have like skin cancer or something.
okay, and then negative.
This chair's so freaking squeaky.
Calm down, Macy.
Macy, you're sitting on like the very edge of it. It's about to like.
All right, the actual mass. So this is the actual mass of a proton. It's 1.6726 times 10 to the negative 24th grams. Super tiny.
That's cute.
Now the mass of the neutron is
Wait, why is there a little? Oh, never mind. My bad.
1.6749 times 10 to the negative 24th grams. Okay? So look how close together these are. Super close. So essentially, like I said earlier, when we actually think about the mass of the proton and the neutron, we think that they are essentially equal to each other. All right? They're not exactly, but when you look at, they're going to round down to 1.67 times 10 to the negative 24th. All right, and then the electron is a mass of 9.1093 times 10 to the negative 28th grams.
Grams. What about pounds?
I don't know.
We learned how to do that, remember?
No.
Yeah.
You can convert it.
Yeah,
What about
you want to do that for us, Macy?
All right. Now, the relative mass, okay? Remember earlier we said the proton has a relative mass of 1. And since the neutron's mass is considered to be equal, what do you think the neutron is? It's also 1. Okay? And then the electron is 1 over 1,840. So it's 1/1840th the mass of both the proton and the neutron.
Why is my nose peeling?
Then you get sun sunburned?
No, I haven't even been in the sun.
All right. Now, the function. Each one of these three subatomic particles has a specific function that it has within the atom. Okay? So the protons is given to you. It is the identity. All right? If you look on the periodic table, you see that blue number up there at the top?
There's
Oh,
like a
yeah.
bunch of blue
Well, in each box.
numbers.
Okay? Every atom has...
Reminder that lockers are not available after first, third, and seventh bells. Please take what you need for first and second, third and fourth, and seventh and eighth, all at the same time. Remember, keep moving. Get what you need and move on. No congregating.
All right. So every number has a different number of protons. Okay? If you want to think about like something practical that the number of protons is like, it's like a social security number. Everybody has their own social security number, and it's not like anybody else's. It's not the same as anybody else's. The number of protons is
What's yours?
unlike any other atom. I'm not going to tell you that, Jimmy. So, the number of protons tells you what atom it is. Okay? So if I said which atom has one proton, you'd know that that's hydrogen.
That girl in that classroom
Okay.
over there just gave me the desk there.
Well,
Give it back.
She was like this.
all right.
What'd she look like?
I think it was.
The function of the neutron is mass. Okay? All that the neutron does is affect how much mass it has. It doesn't affect the identity, doesn't affect the charge. All it affects is the mass. Makes it heavier. So that's why, remember yesterday we talked about how you can have two atoms of the same element that can actually have different masses. That's because they can have different numbers of neutrons. It doesn't affect the identity because the identity is only determined by the number of protons. So neutrons only affect the mass. Okay? It can affect the stability, but we'll talk a little bit more about that later. All right. Anybody have any idea what the electron affects? The electron affects the charge. So the reason why you can have a positively charged atom or a negatively charged atom is because an atom can gain or lose electrons. If it gains electrons, the charge is going to be a negative charge. If it loses electrons, the charge is going to be a positive charge. Okay? And if they have the same amount, which most atoms will, the charge will be neutral. All right? But that's the only way that the charge is affected, by gaining or losing electrons. All right. Now go down to the bottom. Okay, I'm going to show you how to determine some of this stuff. So let's say that I give you the element name of lithium. Okay? Lithium's symbol is Li. Now, I'm going to give you some definitions of some of these words up here. So atomic number, same as protons. Okay, so however many protons there are, that's what the atomic number is. The mass number
Wait, are those the little numbers that are like?
on your periodic table, the blue number, and that's the one on the wall. Not every periodic table is going to make those numbers blue, but on the wall, the blue numbers are the atomic numbers. So mass number, that is the number of protons plus neutrons. Because remember, what are the two heaviest particles in the atom? Protons and neutrons. So those are the ones that you get your mass number from. Now, the atomic mass is the average of all of the atom's masses for that given element. So remember how I said not every atom is going to weigh the same, even if they're the same element? Well, the atomic mass is actually the average atomic mass, and that is the red number that's given up there.
Wait, so it's average of all atoms?
Average of all the masses of the atom for that element. All right, so what's the atomic number for lithium? You gotta look on the periodic table up there. 3. Now, how do I know what the mass number is if it doesn't tell me how many neutrons there are? All right, I'm going to help you with this one. Look at the average mass for lithium.
Subtract the average mass from
Oh.
subtract the number of protons from
Hold on. So the average atomic mass is 6.941. So what does that tell you that the most abundant mass number is probably going to be? Probably 7.
6.9411.
The unit is AMU, atomic mass units. But the mass number in this case would be 7. Typically, you just round this number to the nearest whole number, and that's going to be your most abundant form of that element. It's something called an isotope. Like if you have two atoms that have different masses, they are isotopes of one another. So 7 would be my most abundant isotope of lithium. All right, now, how many protons does lithium have? 3. So the atomic number is 3. How many neutrons does it have if the mass number is 7? 4. And how many electrons is lithium going to have? 3, because it should be the same as the protons as long as the atom is neutral, which as of right now, everything that we talk about is going to be neutral. All right. Let's go ahead and do another one. Let's take nitrogen. Go ahead and finish that out.
Where is nitrogen up there?
It's in.
Nitrogen is N.
Oh, there it is.
So your symbol is going to be N. What's my atomic number? 7. What's my mass number going to be? 14. Because your atomic mass, if you look up there, is 14.0067 AMU. All right, so that gives us how many protons? 7. How many neutrons? 7. How many electrons? 7.
777.
Okay. Anybody confused? Abby?
How do you find how many neutrons are
So, okay. Do you see the red number up there on the periodic table?
Mm-hmm.
All right, so it's 14.0067. So that tells me that the most abundant mass number is probably going to be 14. Because the average is closest to 14.
So you just round it?
Yeah. So that gives you the mass number, and then to get the number of neutrons, you just subtract the protons from that number. All right, let's do one more together. Let's do sodium, which is Na And the atomic number of sodium? Na, left side, first column. 11. Okay, atomic number is 11. What's the mass number of sodium?
23.
23. And what's the atomic mass?
22.9898.
It's good, because I was having trouble seeing that one. All right.
I thought you was right.
Thanks, Macy.
You're a genius.
And how many protons? Should be the same as the atomic number.
11.
11. How many neutrons?
12.
12. And how many electrons? 11. Okay. Should be the same as number of protons. All right. Now, what I want you to do is to, on your own, do aluminum.
Aluminum.
Can you tell us what the symbol is?
Yes, please.
Aluminum is pretty easy.
Is it A?
No, there is no A.
Is it AL?
It's AL.
Thank you.
Do sulfur,
Sound?
S. And bromine.
How are the people back there supposed to see?
Well, they might have to look up a periodic table on their computer. All right. So go ahead. I'll give you a few minutes. Do those. And when you get those, I'll come around and check.